In terms of deployment types, Onum can be deployed on-premise, on the cloud's own infrastructure, or in Onum's public cloud. It can also be deployed in a private cloud owned by a client, but we typically consider this an on-prem deployment, because in the end, the infrastructure is on the client side, and all processing, maintenance, and infrastructure management remain under the client's responsibility. Typically, in the software as a service model, everything is deployed in the cloud, but we have the flexibility to deploy on-premise to adapt to the specific needs of our clients. As for the more client-facing part, the tenant we discussed in a previous video is almost always deployed in the cloud, and it is not usually deployed on-prem. It can be deployed using any Linux machine or a Kubernetes cluster, allowing for a fast and agile deployment in any environment. Of course, Onum can work with any of the major cloud providers, such as AWS, GCP, or Azure. Just as a general reference to give a rough idea of the architectural requirements for on-prem deployments, it's necessary to evaluate the volume of data to be ingested to determine the appropriate number of distributors and workers that need to be included in the deployment, to ensure adequate processing speed and performance. For an on-prem deployment processing around 1 million events per second, or EPS, each virtual machine should have a Linux distribution, around 16 GB of RAM, 8 CPUs, and 500 GB of storage. This is just a baseline reference. At Onum, we create a customized estimate for each client to determine the computing and storage needs. Since processing 1 million lightweight events per second is not the same as processing 1 million heavy or complex events that contain large JSON payloads, etc. This evaluation is done dynamically for each deployment. And to reinforce the message mentioned at the beginning, Onum positions itself at the center, interconnecting components in a completely agnostic way. We can receive data from sources as diverse as Syslog, NetFlow, or Kafka and send it to SIEMs like Devo or Splunk, or forward it to storage environments such as AWS S3.